In this video, I want to show you guys how to take the derivative of a function using the power rule. And you're going to want to use the power rule when you have some variable x raised to some constant n, okay? So for example, say we had the function f of x is equal to x cubed. Well, we have some variable x raised to some power n, which is 3. So the way it's going to look like this. The power rule states that you take the exponent n and you multiply it by x to the n minus 1. So all this is saying is we take the exponent and bring it down to the front, and then we subtract 1 from this exponent, and that becomes our new exponent. So for example, take f of x is equal to x cubed. Well, the derivative of x cubed is going to be equal to, if we take the exponent 3 and move it out to the front, this will be 3 times x, but then we have to subtract 1 from our exponent, so 3 minus 1 is equal to 2. Our derivative using the power rule is 3x squared. So if we simplified this, multiplied 3 by x squared, this will be 3x squared. Okay, so for our next example, we're going to do something a bit harder. Say we had the function f of x is equal to x to the 5th plus 6x squared minus 2x plus 6. And we're going to do this the same way, but we can find the derivative of this by finding the derivative of each term individually. So we'll take the derivative of x to the 5th first. So if we take the exponent and move it to the front, that'll leave us with 5x. And then we subtract 1 from 5. That'll be our new exponent. So 5x to the 4th plus, then we take the derivative of 6x squared. We bring 2 out to the front, but if you look up to our formula, we multiply it by the function. So this will be 2 times 6x, and then we subtract 1 from 2, and our new exponent will be 1, minus, so we have 2x. This is x has an implied first power here, so if we take the first power and move it to the front and multiply it by our function, this will be 1 times 2x, and then if we subtract 1 from 1, our new exponent will be to the 0th power, plus, and then the derivative of any constant is 0, but if I showed you how we took the derivative using the power rule, technically this is 6x to the 0th power, okay? That's what the constant 6 is. So if we moved 0 to the front and multiplied it and then subtracted 1, this would be 0 times 6x to the negative first power. But 0 times anything is just 0, so this equals 0. So to save some time, instead of having to do it like this, just know that anytime you have a constant and you want to take the derivative is 0. So we'll just have plus 0. Then we can clean this up a little bit. 5x to the 4th is fine the way it is. Plus, so 2 times 6 is 12. X, and then the first power, we don't have to write it because it's just implied. Minus 1 times 2x to the 0th power. Well, x to the 0th power is just 1. So this is 1 times 2 times 1, which is just 2. Plus 0, we don't have to write that. So this right here is the derivative of this function up here. So for our next problem, consider this. F of x is equal to x to the negative 2nd power. Well, if you look up here, we want it in this form, x to the n. Well, this is x, a variable x, raised to the negative 2nd power. So this is in this form. We can take the derivative of this function using the power rule, and we're going to go about it the same way. So f prime of x, or the derivative of f of x, is going to be equal to, we take the constant, or the exponent, and we move it out to the front. So this is going to be negative 2 times x, and then we subtract 1 from negative 2. So negative 2 minus 1 is just negative 3. And if we simplified this by multiplying negative 2 times x, this will be negative 2x to the negative third power. That's the derivative to this function. So for problem number 4, try this one yourself. F of x is equal to the square root of x. Okay. Well, if you look at this, is the square root of x in this form? Some variable x raised to the power of n. Well, like this, no, it's not. But the square root of x is the same thing as x raised to the 1/2 power. Okay? Because this is x to the first, and the square root of x has an implied index of 2 here. And the way you do this is to write any square root, or like the cubed root or the fourth root of any variable. The way you do it is you take the inside power, in this case it's 1, and put it on top, and then divide by the index, and in this case it's 2. And that's how you can change any square root, cube root of anything into the form x to the n. So now this is x to the 1/2 power. To take the derivative now, or f prime of x, we go about it the same way. We take the exponent 1/2 and move it out to the front. So this is 1/2 times x. But then we have to subtract 1 from the top. And 1/2 minus 1 is the same thing as 1/2 minus 2 over 2, because we have to get common denominators. So this is going to be equal to negative 1/2, and that's going to be our new exponent. So 1/2 times x to the negative 1/2. If we simplify this a little bit, this will be 1/2 x to the negative 1/2. And if we want to completely simplify this, we can change the signs of the negative 1/2 to a positive 1/2 and move it from the numerator down to the denominator, just to get rid of that negative exponent. So this would be equal to 1/2 times 1/2 x times to the 1/2 power, and x to the 1/2, as we've seen back here, is the same thing as the square root of x. So this is going to be equal to 1 divided by 2 times the square root of x, and this is the derivative of the square root of x.